All right. Hello, everyone, wherever you are. Good morning, good evening, good afternoon. I am Josh Grant, and welcome to the Code Intelligence Coffee Hour, where we're going to have a light and easy chat about various things related to application development, security, and all sorts of other fun things. So, I am your host today, Josh Grant. A little bit about myself. So, I come from a test automation background. I've been working in test automation for, just going to do this. I've been working in test automation for over a decade. I have worked at various stages of the test automation pyramid. So I have worked on at the very top of the pyramid, working with Selenium, working with technologies like Protractor and things like this. JavaScript and Java. I've also worked at the API layer, writing API test frameworks in Python and working with tools like Postman, API Fortress, these sorts of things for testing all of your services and APIs. And I've also worked at the very lowest level, with unit level, where as a developer, I will write unit tests in test-driven development form. But I've also constructed unit test frameworks for open source projects as well. So today we're going down, and we're focusing on that lowest level as a developer. So today we're going to think all about application development and JavaScript application development in particular. So if you're interested in JavaScript, if you're a JavaScript developer, front end, back end, full stack, half stack, then I hope you get something out of this. I hope you enjoy this. And a little bit about code intelligence, which is here actually. So code intelligence, so we help and produce tools that help application developers secure their code. And find functional bugs, security issues, and we help you find the unexpected. So today it is a coffee hour. So I have my coffee here. I hope you have your beverage of choice, depending on where you are in the world, or depending on your preferences. I have my coffee here. It's nice and tasty. And I have a cake. So coffee and cake. So this is a Hostess cake, Hostess cupcake. If you are a resident of Canada or the US specifically, these things are delicious. They're tasty, sugary, very nice. So that's today's cake. Definitely for future coffee hours, let me know if you have any recommendations of any kind of cake or treat that kind of goes with a coffee or tea. All right, so there's that. Yeah, I know, right? They're good. I haven't had one of these in a long time. I almost got Twinkies, did not get Twinkies. Too early for that where I am. So, and I'm coming to you from lovely Toronto, Ontario, Canada. So East Coast, Beast Coast. But yes, wherever you are, I hope you're enjoying things. So the structure of today. So we're going to have a little chat about what it means to think about security from an application developer standpoint. So how you can think about security and how you can think of security from a JavaScript perspective. There are things in common with other languages and ecosystems, such as Java, Python, those sorts of things. But JavaScript has some of its own unique aspects of its ecosystem and tools that can help you think and secure your code. And then after that, we'll do a demo where I will show a very simple React app, so classic JavaScript React app, and show you how Jazzer.js, a testing tool and a bug finding tool, can help you out. So that's Jazzer.js is an open source project, open source bug finder, bug detector, if you will, produced and maintained by Code Intelligence. So let's start with development, and please ask questions. Definitely please ask questions in the chat. They will be moderated. I'm happy to answer them as they come in. If you want to ask me about anything, please ask me. All right, so thinking about JavaScript. So if you have worked with JavaScript for a while, well, I guess I'll kind of take a step back. So what is application security? So an application development security. So phrases like application security, DevSecOps, right? So people are very familiar with DevOps and kind of the web development space, kind of the modern space of software development, thinking of SaaS applications, thinking of big applications from banks and companies you've heard of, all the way down to small applications that maybe are internal use or even hobby applications. So how should developers think about application security? Well, application security is targets or is focused on code. So like as an application developer, you're going to write code, you're going to write a feature, you're going to fix a bug, you have to update something, you have to maintain your code base. All those normal things that you do in the over the course of a day, right? Responding to Jira tickets, opening pull requests, all that kind of fun stuff. So how do you think about it from a security perspective? Well, uh, what code do you have, right? Like what code is there? They're basically all code that you work with as a developer can fall into one of two buckets. Code you wrote and code you're using, but you didn't write. So for code you didn't write, you might want to think about things like supply chain, supply chain security. Where did that code come from? Did you install it through like a package manager like npm? Did you get it from? Did you download it from source? Did you clone it from somewhere like GitHub or GitLab? Is it code that is something internal to your organization? Maybe it's not on your team, but if you're in a big organization, it came from another trusted source within your organization. Did it not come from organization? Did you download a zip file from SourceForge? Did you download a zip file from somewhere even sketchier? Where did your code come from? So when you think about code you didn't write but you're going to use, you might want to think about things like supply chain security, where it's coming from, and being cognizant that it might not be safe. Where it comes from may or may not be trusted, depending on the context. So you want to think about those things. And there's tooling to help you. And if you're in a very large organization, there are whole teams that can help you with this. But if it's just you kind of hacking away on your favorite JavaScript app, there are still things you can do just to keep things safe, keep from, security issues arising, right? Things that are easy. You don't have to be an expert. You don't have to be, an Alyssa Miller. You don't have to be like some VP of application security at Google. You can just kind of take some steps to secure your code. And it's very much like testing. It's very much like test automation. If you're writing code for a professional organization, right, you're going to write unit tests. You're going to have some kind of unit tests to verify that your code does what you think it does, it functions correctly. And security is the same way. You want to maybe do some checks or use some tools to verify that, yes, this code isn't going to lead to a security vulnerability or lead to some problems with security down the line. So that's code that you didn't write. What about code that you did write? Well, I just mentioned unit testing. So unit testing helps you with functionality, right? Does this code do what I think it does? Does this code, code I wrote yesterday, does it work the same way today? You can use tests for that. And so very much in the same way, there's all sorts of tools that you can use to validate that code that you wrote doesn't have any obvious security issues or obvious security vulnerabilities. So what kind of security vulnerability? What am I even talking about? What are some examples? Well, we're going to show that in the demo in a little while. But things you might have heard of are things like SQL injection. That's still very common, believe it or not. Just passing in, and SQL injection kind of falls into this more general idea of injection attacks, where untrusted input goes into a function, into a library, into code that you wrote, and does something malicious. It does something that is unexpected, something that can crash a system or like corrupt a database or do something nasty or something like this. So as a developer, how do you kind of think about these things? There are tools to help you, but also it's important to be cognizant that security is everyone's responsibility, and you should think about security all the time. So I guess let's go to a demo, unless there's any questions or comments about that. All right, sounds pretty good. So code you wrote, code that you're using, but you didn't write. So those are the two things you should keep in mind. Are these things secure? So let's get into the demo, and I'm going to share my screen if that's an option out there. So I'm going to click and All right. Now can everyone see? Unfortunately, yeah. So here it is. Here is my. I just want to make sure that like people can see this. Um, so here is my sample application. So this is a very, very simple application. It's a React app. If you've done now old React app tutorials, this will look very familiar to you, but it's very simple. And so what is this app? Let's start it up here. Okay, so here, so this is a Celsius to Fahrenheit calculator. So it's a very basic web application. You basically have two inputs. You can enter a temperature in Celsius, and then you can enter a temperature into Fahrenheit, and it will compare the two and give you the conversion. So, for example, if I put in 100, so 100 degrees Celsius, boiling point of water is 212 degrees Fahrenheit, very, very hot. And if I put in 0, so 0 degrees Celsius, which is kind of cold, freezing point of water, it's 32 degrees Fahrenheit. So pretty straightforward. It's pretty nice. I can kind of test this here. If I try to put in text, nothing happens. That's pretty clever, because it doesn't make sense. How do I convert this? It's not a numeric value. It doesn't do it. So this app looks pretty good. And as a good developer, in addition to writing this in React, I have written some unit tests. So good practice. So good practice. I have separated out the logic of calculating this conversion from Fahrenheit to Celsius. I've separated out from the pure front end code, which generates the inputs and React uses to construct the actual web application. And I have that in its own class, which is down here. So I have a calculations.js. So what does this do? Well, how can I explore this? If you use your imagination, like this is a very simple web application, but if you use your imagination, you might think to yourself, what if this was a piece of code in a very large organization? Maybe you're new on the team and there's like lots of different things to look at. It's structured weirdly. Maybe you're looking at kind of a piece of functionality. So how do you get a handle on it? Well, the first thing you can do is run some tests, right? See if the tests run, see if they pass, and then you can take a look at the test to see what they're checking and what they do. All right, so I'm going to run npm test. So here I am running some tests, and these tests are using Jest, but you could use your favorite test runner as well. So if I go look at calculator test, so here it is, right? So here it is. So I'm importing my calculations and I'm testing. I have two tests, one to verify that my Celsius is getting computed correctly, and one to verify, oh, and there's a typo. Of course there is. And one to verify my Fahrenheit. Got it the first time. One to verify my Fahrenheit calculation is correct. So both cases, I kind of just walked through exactly what I showed. Is 0 degrees Celsius, 32 degrees Fahrenheit. That's one test case. Is 100 degrees Celsius, 212 degrees Fahrenheit. So I have these tests, they're running. So my unit tests run and pass. My web application runs. Everything's good, right? There's simply no problems that I'm looking at. Well, there could be though. So let's go back to let's see here. npm start. Let's go back to npm start up my app, right? So it looks good, it's running, and it's running on my local host, but you can imagine this running on a staging server or a test server or something like this. And so let's look at what the warnings say. So always take your warnings seriously. So some projects, some configurations, I don't know about JavaScript, but other languages, you have errors and warnings. and you can configure things to set warnings as errors. So you can say that like we're actually going to treat warnings as errors. They're going to stop building the application, stop the compilation process. And so here we have a couple of warnings. So maybe we should pay attention to them and see what they look like. So here we have, we have an equal, equal. Okay, so this one is a common thing. That's bad on me. But you should use triple equals for like, actual equality. So that's something interesting to look at. The second one is even more interesting though, especially if we are wearing our security application security hats and thinking, how could how could this code be used to do something malicious? How could this expose a security issue, code that I wrote or code that I'm using? How could that expose a security issue to the code base or to sort of the wider organization? So, and that is here. So eval can be harmful. Okay, so that's interesting. So if you haven't seen it, so eval is a statement. It's common in a bunch of different languages, um, in JavaScript, Python, Ruby, not Java. That's good news. Where you can pass in an arbitrary string, and then that string will be treated as a calculation. So if you pass in 3 plus 2, you'll get 5 as an eval, as a result of eval. So eval is helpful if you want to just pass in things and evaluate an expression. But it can be a security issue because if you pass in something that does something malicious, such as eval, execute, like insert this class or like delete this class or something like that, you could do something, or a malicious attacker could take advantage of that. So eval is something to be sort of avoided, but where is eval? Where could this eval be? So let's take a look. Where could it be? It says line, in calculations. Well, that's interesting. So before I open up calculations, I want to stress one, everything looks just ducky. Everything looks fine from running tests and running the application. So everything seems okay. I also want to stress to people to use their imaginations and think that like this is a large code base. Imagine some of this code has been worked on for months or even years. People have come and gone. Decisions have been made that you weren't present for, or you may not understand, or may not be documented well. So, and I have seen this. I have seen all sorts of crazy things in tests. So, and in application code as well, and test code additionally, things that make you go, what? Why would you do this? Why would someone do this? And these things do happen all the time. So let's take a look at this. So we're going to go down to line 21 and look, there's an eval statement. So the way this toCelsius function has been written, instead of just computing the number as needed, someone used an eval statement. So this means that you could pass in something to this function and do something malicious, or you could kind of do something highly unexpected. And you would catch this, or you would be tripped up by this eval statement. So to recap, this works. It works, gets by unit tests, gets by kind of basic testing, but there could be a security issue here if you pass in something malicious. So already you can see how it's easy to get misled by like purely functional thinking, by purely like, does my application work? Do the happy paths work? Are there other things? So on that note, let's take a look. Oh, I don't need to start that. Okay. So let's think about like how we can test or how we can kind of look at testing from a security standpoint, because maybe there's some other unexpected things or other aspects of this code that might jump out at us as to be like, this is a problem or this is a security issue. So what I'm going to do, so I've run my unit tests and they all passed. There's only 2, but they all passed. So now I'm going to use, and I'm going to get into this demo mode. I'm going to use Jazzer.js. So what is Jazzer.js? So Jazzer.js is a fuzzer, a security application or a security fuzzer, I guess is the best way to say it. And this is something that explores your code and tries to. So what a fuzzer does is generate fuzzy input, semi-random, quasi-valid, fuzzy inputs, and it will use that to explore your application or your system under test. In this case, this function or these functions like 2 Celsius and 2 Fahrenheit, and try to pass in values that trigger error states or find malicious bugs or these kinds of things like security issues. And it will do this automatically. So, so I'm going to do the demo. The demo is very quick, and then we'll kind of talk through it. So I have these unit tests. What else could I do? Well, first, what I could do, so let's take a look at Fahrenheit fuzz. So here I've written some code. So just for comparison, so if we take a look at here, so here's like a standard describe block. So if you're in JavaScript, but also from Ruby, this will look very familiar to you. Let's get rid of this. And let's get rid of this. So here I've written my nice unit tests. They're all structured really well. I have some assertions. So I'm verifying that my code works the way I think it does. So functional. But I might want to also explore this function or these functions or the system under test or however you want to think about it. I want to explore these functions and try to find bugs or security vulnerabilities. So what I'm going to do is I'm going to write another test. These are functional tests. So I'm going to write a separate set of tests, which you could think of as fuzz tests here. So what I've done here is I'm using Jazzer.js. So I do npm install save dev Jazzer.js, and I'm going to install core. So this installs all the utilities that I need. I have done this previously, but just so that you all believe me, I've just installed it again. All right. Oh, and look, there's some, looks like there could be some vulnerabilities here. So just for fun, actually, let's just go npm audit. What does npm audit do? So going back to what I was talking about, this is a really common use case I find for npm and for JavaScript. If you're using Node, you install packages, right? I was doing some work the other day, and I got an error, and it said you're missing this package, and I said okay, npm install this package, and it's like, oh, now you're missing this other package. Okay, npm install this package. Before you know it, you've installed like half a dozen different things. Maybe you don't even know what they do, or like, okay, well, AWS SDK, sure, I know what AWS is. And you're installing these things, and you may not quite know where they come from or what they're used for. And then once you install them, they're a part of your system. So in this case, I know exactly what this is and why I'm using it, but I'm still installing it. And there are some vulnerabilities. So npm will alert you as a package manager. Here are security vulnerabilities. They can be low, moderate, high, or critical in terms of their severity, which are based on things that security analysts and security researchers have sort of identified as low, medium, high type critical levels. And so what I can do with npm audit is, if you haven't used it before, I recommend using it. I recommend kind of putting it into your JavaScript workflows. You can kind of see what code is causing possible issues in your supply chain. So when I talk about a supply chain, that's when you run npm install, or if you're using other programming languages, when you run npm install, that will install like the software that the libraries that you're looking for. Those libraries also have dependencies, and those dependencies have dependencies, and so on and so forth. So npm audit will sort of search through what you're installing exactly and say, okay, this library has this known issue. This library has this known issue. It's critical. You should really think about fixing it. So npm audit can give you all this information here. I'll just make this a little bigger. And it can give you severity, and it can also give you the option to fix things up. So for example, let's look at, so something when I installed Jazzer.js, something is using this node notifier library, and I can get more information on this. So because I'm using this, and because I'm using this lower version, right? Like this is kind of the tip, or this is the suggestion that NPM audit would give. There's a moderate severity issue, something in this node notifier library. And so one idea is to upgrade my jest, my version of jest that I'm using, or I mean, if possible, I could also, if I'm using this directly in my package JSON, I could update this as well. So there's some ideas, but also this sounds complicated. As someone who's tried to manage dependencies in Node.js projects, even bumping up or lowering one dependency version can cause like a lot of issues. So NPM audit does provide some functionality here. Like you can run NPM audit fix, and it will try to resolve some of these things. So good practice. If you are in a very security conscious environment, if you are a bank, or if you're working for a bank, I mean, you're not going to be a bank, people aren't banks. But if you're working for a financial institution or a large bank, or if you're working for somewhere with intellectual property that's highly confidential and needs to be kept pretty secretive, then you might want to take this stuff very seriously. You want to integrate these kinds of things into your workflows. So that's a little digression on supply chain and other people's code that you might want to take care of. But I'm going to use Jazzer.js. I'm very confident in its abilities and its security levels. So for my context. All right, so I've installed Jazzer.js, and now I want to, so I've written this test. So currently with Jazzer.js, it provides a command line utility called Jazzer, based on the Jazzer product or utility, I guess, which is also provided by Code Intelligence. Jazzer is a Java-based security testing tool. Recommended if you're in the Java world, but we're in the JavaScript world, completely different, nothing alike. So we're going to use this utility. So if I use npx Jazzer, now I can execute fuzz tests that are written in this way. So I'm just going to walk through what this looks like. So here I'm defining a single function called fuzz, and it takes an input. Okay, and the input's a buffer. So a buffer is just like a set of bytes, I believe bytes, in JavaScript. But I can use that to generate this fuzz data provider. So what is a fuzz data provider? So this is something, if you think about a data provider, if you've used utilities like Faker.js, or if you're from the Java world, if you use something like TestNG, these are test tools that have a data provider concept that will generate test data for you. So in the case of Faker.js, that'll generate random values of strings or numbers, or can give you a random valid email address or like that sort of thing. So here, this fuzz data provider is something that will generate fuzzy data that will loop through and test this function under test with integers. So I get this fuzz data provider, I create this new data object, and then I generate integrals. So I'm creating an integral value, so an int, and in this case, an int of up to 4 bytes large, which is short or something. I don't know. Didn't do so well in computer science. But anyway, it generates this integer value that I can use to test, right? So I want to verify like my 2 Fahrenheit test. Are there any integral values that could cause a bug or could cause an issue? I mean, I've tried a couple. I've tried 0. I've tried, or sorry, 2 Fahrenheit. Yeah, I've tried 0. I've tried 100. They seem to work. So like, where's the problem, right? Could there be other cases? Well, there could be other cases, but the beauty of this fuzzer and this utility in Jazzer.js is that it will generate values for you. It will come up with values that are interesting, and it uses intelligent technology to kind of go towards interesting use cases. So let's run this, because I've defined this function. You can kind of think of this as a test case. So I'm going to run this test case using Jazzer. So I go like this. Oh, and first thing I'm going to go to source. And I'm going to go npx because that's where this file is located. So I'm going to the same location as to where I've defined this fuzz test or this fuzz target. And I'm going to use Jazzer, and I'm going to go Fahrenheit fuzz. Oh, that was fast. Whew, didn't even have time to have some of my coffee. So let's see what outputted here. Okay, so there's some startup. So this is telling you like how the fuzzer is getting started. It provides a seed because again, this is not random, but it's sort of intelligent, guided by some artificial intelligence in the very classical sense. So there's some algorithms that sort of guide what inputs to generate how. And so there's some startup things. But then there's this uncaught exception, PC load letter. Well, what does that mean? Right? PC load letter, like that doesn't make any sense. What exception is this? This uncaught exception was generated from a given value. Maybe it was generated from, yes, this was the sort of the byte representation of this value. So like what happened? So like, let's take a look at the code because this uncaught error. So uncaught exception, PC load letter. What does that mean? So let's go back to calculations. Let's take a look at the code. Okay. So, and here again, in this world, like if you imagine this is not just a simple project, but it's a complicated project in like a large organization that's existed for a relatively long time, you'll see that like there's some very weird logic. So it looks like the 0 Celsius and 100 degrees Celsius cases are being hard coded. Again, maybe there's a reason for this. But then there's also this weird thing where if you put in a number divisible by 23, you get PC load letter, right? And again, this is very mysterious. This is a really weird implementation. And otherwise, you get -1 for some reason, right? So this is a really weird piece of code. This is like really questionable. But notice that a unit test or a simple unit test might not find these sorts of things. Very simple happy path tests may not find these things. And our main application does work, right? The main application loads and does appear to function properly. So again, you might not think of these cases. You might not think like, well, what happens if I put in 23 degrees Celsius? Or what if I put in a multiple of 23 degrees Celsius? Can I replicate these things? Like this is a weird bug. And again, there could be reasons for this. Maybe this function had to be written very quickly to get it out the door for like a really important demo for like a really large bank that you have to demo to. And it's very stressful. Yeah. Or maybe, this is a junior developer just, trying to work through how to do things. Not quite sure of like maybe JavaScript isn't their first programming language or their preferred programming language, that kind of thing. But the point is that this function does kind of work, but it has this weird structure and it has this weird bug. So that's really easy. And so you might not think of this, but if you use a fuzzer and if you use some kind of bug finding thing, you can find this issue. You can find issues like this very, very quickly. Like that was like well under a second. And data was generated, tests were executed, things were fast. So that's really good. So like, what about fuzzing the other? What about fuzzing? So why not write a fuzz test for our other function, right? The Celsius.fuzz. So here, let's try this out. So we're going to go Celsius. Okay, now here it's starting up, same idea. So we have some kind of random seed and values being generated. So this is taking a little bit longer. This is taking a little bit longer to find. And I think, let's take a look at calculations. I think in part, the reason it's taking longer is that you've got this eval statement. So currently, um, so eval is something that is flagged by Jazzer in Java. So eval is a security issue, as kind of mentioned. And this is the kind of thing that Jazzer and Jazzer.js should be able to find. So currently, I know that Jazzer.js is, is bug detectors and sort of functionalities of finding these style of bugs are being worked on. And so this is one thing. All right. So, and as you can see, I also want to mention, like, when it comes to security testing, um, you can run like, I guess what I should say is that, so security testing can be exploratory in nature. So that means that, unlike functional testing, where, like, if you're expecting 42 and you get 41, that's a bug or that's a failed test, and that's something to look into immediately. Like, that's very deterministic. Uh, Security testing can be a little more exploratory. You're looking for something that might not be there or may be there, and you want to try to validate what possible things are available, or like what possible issues you could run into. All right, so I'm going to stop this actually. And so this is future work. Luckily, React found this for us, but in the future, Jazzer.js will be able to find this kind of thing as well. And I think that concludes kind of the demo portion of this. I will. Oh, and let's make this a little bigger. So I will mention, definitely check out Jazzer.js, npm install, save dev, I guess, if you need it, Jazzer.js core. So you can get that through npm. You can also take a look on our GitHub. So you can also take a look at code intelligence testing, or github.com/code intelligence testing. And you'll find the repository for Jazzer.js, as well as some other things there too. As well, and I would be remiss if I did not mention, so you might think, well, Josh, this is all really great and I love this, but I'm a Java developer or I'm a Kotlin developer. I can't do this. I can't use this wonderful utility. Don't worry, we've got you. You can also use CI Fuzz. CI Fuzz is a central command line utility, which sort of under the hood uses these security testing tools for a variety of languages. Currently, CI Fuzz supports Java, JavaScript, and C++. So definitely check that out. JavaScript is coming soon. So definitely take a look at that. And if not, you can also use you can use Jazzer in Java or Kotlin directly, or you can use Jazzer.js directly for JavaScript as well. So yeah, that kind of concludes the demo. So I'm happy to take questions, comments. I haven't tried my cake yet. So yeah, let's close this down and stop sharing. All right. Any questions, comments? Ooh, what kinds of bugs can Jazzer.js catch? Okay, so great question. So, it's a great question. So as I mentioned, so Jazzer.js can find exceptions that are thrown. So if you have error cases, so if you raise if you throw an exception, Jazzer.js can find those code paths to get to there. Coming soon are bug detectors for things like SQL injection and eval comments, so injection attacks. So that's something that is being worked on. So security bugs as well as functional bugs. Oh, does Jazzer.js have any integrations? Yes. So I used Jazzer.js directly. So that provides the command line util from Jazzer. There is an integration in the JavaScript case. There is an integration with Jest. So if you are a Jest user, if you are running tests using Jest, you can also integrate directly with Jest. And there is a runner configuration, something like Jazzer.js / Jest runner, I believe it's called. So you can check that out. and you can use that to turn your Jest tests into Fuzz tests. So it's a nice little integration there. Will Golang be supported in the future? Oh, that's a great question. Yes. So yes. So currently, I'll take a few steps back. So Jazz.js is JavaScript only, as in CI Fuzz. So CI Fuzz is the main command line for cross language. So currently supported is Kotlin, Java, and C++. JavaScript and Golang are for the future. So I don't know which one currently has priority, but there is work being done to support Golang and Golang security testing. So stay tuned for that as well. All right. Any other questions? Like anything? Any questions or comments? Was the cake good? How about you try butter tarts? How about you try streusel? I don't know. I'll take suggestions. But yeah, if that's yeah. All right. So to recap, so I will. Yeah, let's do this. So do GitHub. So for more information, also we love open source. So a lot of our utilities right now are available open source on GitHub. So I will pass this into the chat somewhere. Let's go here. All right, I guess we'll do like this. So in the chat, we'll post the Code Intelligence GitHub. So this is a great place to go if you're interested in what we're up to, what Code Intelligence is doing. Also utilities and tools that are coming up. So yeah, definitely take a look at that. Take a look. There are many test tools you can use. You can clone from source, or you can install through npm, or in the Java case through Maven Central, like that kind of thing. So definitely take a look. There's some fun stuff happening there. If you want to know, like, how do these things work, or like, what when you say intelligent testing, or you say like an intelligent algorithm, like what does that look like? There it is. You can take a look at the code there. I will say that there are some, this kind of security testing and this AI guided security testing and fuzzing is being worked on by some very smart people. It's definitely not a new technology. So these algorithms have been around for a little while now, since at the very latest, the mid 2000s, the mid noughties. So they've been around. They are real things, but they're really smart. They're really smart, and this is a good implementation. So CI Fuzz is a really good implementation, really user friendly if you're getting started for the first time. And feedback's welcome. Open an issue. Reach out to me, Josh at codeintelligence.com. If you have any questions or comments about like any of the technologies I've showed today or anything I've mentioned, I'm definitely happy to answer questions. So yeah. All right. So on that note, it is a lovely sunny day here in Toronto, so I will wrap up. Definitely reach out if you have any questions, and please join in the next coffee hour, which will be in approximately a month. And we're going to be talking about APIs. We're going to talk about API testing and security, and it should be a good time. So thank you very much for joining, and enjoy your day.